The next step on the genetic matter. After the Hershey-Chase experiment and the declaration of DNA as the genetic matter, the next race that it started was the race to find the structure of DNA. Okay, and that was, it's just like today, where all the scientist world is, in a race to find this vaccine for COVID-19. Okay, so in the same way, they had a tough competition everywhere. But in 1953, just a year later, James Watson and Francis Crick, and I believe James Watson was no relative of Sanjeevan, and hopefully not, because there's an interesting story behind it. They were people who constructed models of different organic material. Okay, and they had come up with this DNA structure, and where they had drawn this, they knew that it had this sugar phosphate chain, and attached to it, the bases were there, nitrogen bases. They knew it, okay? And then, but they did not know how it was structured. So their model was something like this. This was the double helix one. What do you call it? The first strand, and this is the second strand from the two strands of a double helix, and they projected the bases at the side like that. So this was their initial presentation, and they did this or presented this in 1951. Most of the scientists did not believe, or they could not accept a lot of things in this structure at all. So things were not holding at all, not adding up at all. They were struggling to get the actual, the structure of DNA. And there was another lady known as Rosalind Franklin, who was experimenting on similar line. Now, there's a very famous photograph. Now, she used to take photographs of X-ray photographs, and she was using this X-ray for a long period of time in order to get the picture of or photographs of the DNA structure. And for one of the photographs that clearly showed the double helix nature or the structure of the DNA was called photo 51. Okay? And this photo 51 somehow got in the hands of James Watson and Crick. Watson and Crick, when they saw that photograph, they immediately knew what it was all about. For us, when we look at that photograph, it does not speak a lot at all, because it merely looks something like an X kind of. So, okay. But when Watson and Crick saw that photograph, they immediately knew what was happening, what was the reality of the DNA structure, and right after 1 month, they took out their double helix model, which we now study, which is well accepted, in 1953. Something else happened in 1953. Tenzing Norgay and Edmund Hillary climbed Mount Everest. Well, that's not going to be exemption. Right. Then we have this DNA structure. Okay. Let's deal with two terms here. Nucleoside. What is a nucleoside? It's the sugar and phosphate base. Sugar and phosphate chain without the nitrogenous base. It's known as nucleoside. Now, when a nucleoside is attached to a nitrogenous base, then it becomes a nucleotide. Okay, nothing very difficult to understand. Something which is very important to understand is this. This DNA strand, this is one strand, and the other one goes behind it, like that. They're not joined, but they come in close proximity with a hydrogen bond in between. Okay, we'll talk about that hydrogen bond later again. So this is it, and one side is, we call it antiparallel, meaning one side is facing downwards and the other side is facing upwards. They have, opposite directionality. Okay, which we'll try to understand. In order to explain that, I just brought a very simple thing that you probably have seen. What is this? What is it, man? This is a pentose sugar. Okay, in case if you don't know, this is a pentose sugar. It has 5 corners, and each of these corners have carbon except for the top one, which is marked red. That's where an oxygen is. But we say that it's a 5 carbon structure. So this is the first carbon, carbon 1, carbon 2, carbon 3, carbon 4, and the 5th carbon is present on the top of this. Okay, so these carbons are named carbon 1 prime, 2 prime, 3 prime, 4 prime, and 5 prime. So this is 3 prime, this is 5 prime, this is 4 prime. Something else. I've got another one, another pentose sugar, which attaches itself like this. This one fixes itself on the bottom. This number, this carbon is called carbon 3 prime. Okay, so this fifth one actually fixes up with 3 prime. Okay, in the point. I'll come back later. So what I'm trying to get at is this. This is oxygen. This is carbon number 1. So 1 prime. This is 2 prime, 3 prime, 4 prime, and the 5th one is present here. So that's 5 prime. And we always say that a nucleotide has direction, meaning if this is the sugar base, okay, pentose sugar, and this phosphate group made with this, okay, and a nitrogenous base attached. So this is a nucleotide. But you cannot fix another nucleotide to form a long chain any which way you want to. It has to be in a particular manner. That means it has to be in a 5 prime to 3 prime manner. Okay, the 5 prime has to come here and join with the 3 prime of another predecessor here, like that. So it has its, this is the 3 prime, it has its 5 prime here and 3 prime here. So this gives direction to a nucleotide as well as a chain of nucleotide. This will become the 5 prime end. 5 prime end, this is going to be the 3 prime end. Okay? So this is one chain, one strand. On the other side, there's another one. I'll start with the base, nitrogenous base. And there's going to be this sugar and the phosphate down here. Okay? Again, the phosphate here, sugar and nitrogenous base. So it's turned the other way. So this is 5 prime. This is 3 prime. 5 prime, 3 prime. I'm writing it upside down because 5 prime here, 3 prime here. So this is facing this way. downwards, okay? Whereas this is facing upwards. So this gives this anti-parallel what we call structure. It's nothing. You may say, what's the deal? When it comes to replication, what's replication? Replication and transcription. What's the difference, man? Replication is the copying of the entire genome. Entire genome meaning the entire set of DNA. Okay? Whereas transcription is the copying of just a portion of the DNA in order to make a particular type of protein. Okay, that's transcription. But in both the cases, this 3' and 5' end or this direction has a very important role to play. So more of that later on. Okay, so 5' end has a phosphate group. 5' end has a phosphate group. Okay, so here this is the 5' end. This is the 3' end. Okay, 5' end has a phosphate group. This phosphate belongs to this pentyl sugar, and the 3' end has a hydroxyl group. OH is down here. Okay, this phosphate belongs to this pentyl sugar, and this has OH here, and this phosphate group belongs to this sugar. So this is the way they are attached, and in between these two nitrogenous bases, there's this hydrogen bond that pulls and sticks the two strands together. Right? Now that can be broken up, and it will be broken up during the process of replication and transcription, which we shall see later on. Okay.